Welcome to Tech Road, the podcast that powers up your tech career one episode at a time. I'm excited for today's deep dive because, well, we're really stepping into the future of Android development. You've sent us a fantastic stack of sources, all focused on Google's modern toolkit for building native UI in Android, Jetpack Compose. Let's dive deep into today's tech topic.
Yeah, this is a great topic. And what's really fascinating about this deep dive is it's kind of designed as a rapid shortcut for you. We're aiming to distill the core insights from these materials, focusing on those fundamental concepts you'll need, whether you're prepping for technical interviews or, just trying to solidify your knowledge in this landscape, which is evolving pretty quickly.
Exactly. Our mission today is really to cut through the noise, give you that concentrated dose of impactful knowledge. So, okay, if someone is just starting to navigate this new era of Android development, what's the absolute first thing they need to grasp about Jetpack Compose? Let's unpack the fundamentals first.
Right, let's do that.
All right, so let's start at ground zero. What exactly is Jetpack Compose, like at its core?
Okay. At its core, Jetpack Compose is Google's modern declarative UI toolkit. It's specifically designed for building native Android apps. And maybe the most important point here, it's built entirely using Kotlin.
Kotlin. Okay, so that's a huge shift right there from what many Android developers are used to. How is it fundamentally different from the traditional XML-based UI development that, well, has been the standard for so long?
Yeah, the core difference is really in the approach. So instead of using separate XML files to visually describe your UI layout.
Right, the layouts we all know.
Exactly.
Yeah.
Compose uses Kotlin code directly. Your UI is defined right there in your application logic. It's a declarative paradigm. You basically describe what your UI should look like for a given state, rather than spelling out how to achieve that state step by step, which was, more the imperative style of traditional XML and view systems.
Gotcha. So it's not just a new library, it's really a new way of thinking about UI development. And is it like a standalone tool, or is it plugged into a bigger ecosystem?
Oh, it's deeply integrated into Google's Android Jetpack suite,
Yeah.
which is, that whole collection of libraries designed to help developers follow best practices, write quality apps more easily. So it definitely leverages and enhances that whole ecosystem.
Makes sense. Now, when we talk about building with Compose, the term Composables comes up constantly. Can you explain what these are? Why are they so central?
Composables are, they're the absolute foundational building blocks of your Jetpack Compose UI. Think of them simply as functions, just regular Kotlin functions, but they're annotated with @composable.
Okay.
These are little units you piece together, almost like Lego bricks, to describe every single part of your UI. Could be a simple text label, could be an entire complex screen.
And that composable annotation you mentioned, what does that actually signify? What does it tell the system?
Right. So it's a special marker, specifically for the Compose compiler. It tells the compiler, hey, this function can generate UI elements, and importantly, it can call other composable functions. Without that annotation, your functions wouldn't be recognized as UI components within the Compose framework. It's basically how Compose knows what to draw on the screen.
Okay, that clarifies it. Now, for many developers, especially those on larger teams, there's a huge investment in existing XML-based UIs. Can we still use traditional views alongside Compose, or is it like an all-or-nothing switch?
No, absolutely not all or nothing. That's a really critical point for adoption, I think. You can definitely migrate your app incrementally or just use both side by side in the same screen even.
Really? How?
Yeah, you integrate traditional Android views into your Compose hierarchy using a special composable called Android View. So that allows for a much smoother transition and lets you leverage existing, maybe complex custom views you already have.
That's a huge relief, I bet, for folks with big existing code bases. What about backward compatibility? How far back can Compose actually go in terms of Android API levels?
It's pretty flexible there too. Compose supports Android 5.0, which is API level 21, and anything above that.
API 21. Okay, that covers a really large portion of active Android devices out there.
It does.
Now, when you fire up a new Compose app, maybe from a template, there's this function called set content that you see right away. What's its role? Why is it so important?
Set content is essentially the entry point for your Compose UI within an Android activity. It's the function where you define the root composable function that will actually be displayed on that screen. It initializes the whole Compose runtime for that activity and sets up the UI tree. So yeah, everything you build in Compose really starts from that set content call.
Got it. Entry point. Okay, this all sounds incredibly promising, very modern, But, theory is one thing, production is another. Is Compose just for new projects and maybe experimental features, or is it actually seeing real-world, large-scale adoption? Like, where is Compose currently being used out there in production?
That's an excellent question, and I think the answer really speaks volumes about its future. If we connect this to the bigger picture, you see major Google applications, think the Play Store, Gmail, they are actively adopting and using Compose in pretty significant parts of their production apps.
Wow, okay. Play Store and Gmail?
Yeah. So this isn't just some small-scale trial. It represents a real commitment to the technology across some of the most widely used Android apps on the planet. That's a strong signal.
That is a strong signal. Okay, good foundation. Now that we understand the building blocks and how Compose fits into the ecosystem, let's talk about actually arranging those UI elements on the screen. What are column, row, and box in Compose? Why are they so fundamental for layouts?
Right, these are your absolute foundational layout composables. And they're pretty intuitive, actually. A column arranges its children vertically, so one below the other.
Makes sense.
A row arranges them horizontally, side by side.
Okay.
And box is what you use when you want to stack elements on top of each other. Think overlays, or maybe positioning something in the corner of another element. They just give you really powerful, flexible control over how your UI elements are positioned relative to each other.
Cool. And when we want to style these elements or maybe add behavior like courting, we use something called a modifier. Can you unpack that a bit? What is a modifier and why is it so powerful?
Modifiers. Yeah, they're like your Swiss Army knife for composables. They really are. A modifier lets you apply styling things like padding, background colors, setting specific sizes, and also add behaviors like click listeners, scroll behavior, even drag and drop functionality.
Okay, all in one place.
Well, you chain them together. And what's really crucial for developers to remember is that you can chain multiple modifiers, and the order in which you apply them really matters. It can significantly affect the final look and behavior.
Order matters. Good tip.
It gives you incredibly precise and, well, composable control over your UI's appearance and how it interacts.
Nice. That makes sense for building dynamic UIs. But what about keeping track of data, maintaining state? When the UI updates, this is often a tricky area. What is remember in Compose? Why is that so important for state?
Remember is absolutely crucial. It's for storing state that needs to persist across what we call recompositions, basically, redraws of your composable functions. Essentially, when a composable function runs again to update the UI, remember ensures that a value you've stored inside it doesn't just get reset to its initial value.
Okay. It holds on to it.
Exactly. Think of it like a small local memory for that specific composable instance. If you have, say, a counter that goes up when a button is pressed, remember, make sure that counter keeps its current value each time the UI around it updates.
Got it. Okay, speaking of button presses, how do you actually handle user interactions like click events in Compose? Is it still like setting on click listeners the old way?
It's much more streamlined, I'd say. You typically use the .clickable modifier.
Another modifier.
Yep, you apply it directly to the composable you want to make interactive, like a button or even just a text element. This keeps the interaction logic tied directly to the UI element itself, which generally makes your code more readable and sort of self-contained.
Nice. And just quickly, if you want to display a simple image, what's the composable for that?
You'd reach for the image composable. You just need to provide it with a painter resource to tell it what to draw. That could be from your app's drawables, maybe fetch from a URL or some other image source.
Okay, image with a painter. Simple enough. Now, for displaying long lists, like a social media feed or a contacts list, things that can get really long, we hear about LazyColumn. What is that, and how is it different from a regular column? Why is the lazy part so important?
LazyColumn is honestly a game changer for performance with lists. Think of LazyColumn like a really efficient chef who only prepares the dishes that the customers can actually see on the menu right now instead of cooking everything in the entire cookbook all at once.
I like that analogy.
Yeah. This lazy loading means it only composes and lays out the list items that are currently visible on the screen, plus maybe a few extra just off-screen for smooth scrolling. This makes it incredibly efficient for long lists. It keeps your app feeling really smooth and responsive, even if you have hundreds or thousands of items.
And the regular column doesn't do that?
No. A regular column composes and lays out all of its children immediately, all at once, which, as you can imagine, can quickly become a performance bottleneck if you have more than a handful of items.
Right. That makes perfect sense. The lazy approach is key for scale. But what if you do have a regular column, maybe for a shorter list, but you still need it to be scrollable? How would you do that without switching to LazyColumn?
You can definitely add scroll functionality to a regular column. You do that by applying another modifier, vertical scroll, remember scroll
Oh,
state?
remember scroll state. Okay.
Yeah, that essentially wraps your column content in a scrollable container. But critically, remember, it still renders all as children at once. So it's really best suited for content that isn't excessively long, where the performance hit isn't noticeable.
Got it. Use LazyColumn for long lists, vertical scroll for shorter scrollable content.
That's the general idea, yeah.
Okay, let's shift gears slightly to state management again. It's often where developers spend a lot of time thinking and optimizing. Beyond remember, what is mutable state of in Compose? Why is it so fundamental for making state observable?
Right. Mutable state of is another core building block for state in Compose. It's how you hold state that, when it changes, should automatically trigger the UI to update. When you wrap a variable, say a counter or a piece of text, with mutable state of, Compose knows to watch it.
Watch it for changes.
Exactly. It observes it. And when that value inside mutable state of changes, Compose automatically triggers what we call recomposition, which just means it redraws the specific parts of your UI that actually depend on that piece of state. It's the key mechanism that makes your Compose UI reactive to data changes.
Reactive. Okay. And then there's another one, remember savable. How does that differ from the plain remember we talked about? And when would you specifically choose remember savable?
Good question. Remember savable is very similar to remember. It also preserves state across recompositions within the same activity instance.
Yeah.
But it has the crucial added benefit of surviving configuration changes.
Like screen rotation.
Exactly like screen rotation. Or when the Android system might kill your activity in the background due to memory pressure and then recreate it later when the user comes back.
Yeah.
So if you have user input in a text field, for example, using remember savable ensures that text isn't lost if the user rotates their device or briefly switches apps. It acts like a temporary save point for that UI state across these potentially disruptive events.
That's super useful. So remember, for simple state during redraws, remember savable for state that needs to survive rotation or process death.
That's a good way to think about it, yes.
Now, many Android apps rely heavily on viewmodels from the architecture components library for managing UI-related data, handling business logic, surviving configuration changes. Can we use viewmodels easily with Compose? And are there best practices, especially for larger apps?
Yes, absolutely. Compose integrates beautifully with the existing Android view model. There's a handy view model, composable function provided by a library artifact, Android x.lifecycle.viewmodel.compose. This makes it incredibly easy to get an instance of your view model scoped correctly to your activity or navigation graph and connect your UI to its data in a lifecycle-aware way.
Oh, cool. So it just works.
Pretty much, yeah. And for best practices, especially in larger apps, the common pattern is to keep your composables relatively dumb, meaning they mostly focus on displaying the UI based on the state they receive and emitting events upwards, like button clicks. The view model then holds the actual state, often exposed as state flow or using mutable state of inside the view model, fetches data, handles the business logic.
Separation of concerns.
Exactly. This separation keeps your UI components simpler and more reusable, and your logic more testable and maintainable. It's a solid pattern.
Makes sense. We've mentioned this word recomposition quite a few times now. Can you explain in a bit more detail what it actually is in the context of Compose and why its efficiency is so critical?
Sure. Recomposition is Compose's really smart way of updating the UI. Think of it like this. Instead of redrawing the entire screen every time something changes, Compose is much more granular. Imagine a spreadsheet where only the cells that actually change based on a formula get recalculated, not the entire sheet every single time.
Okay, that's a good visual.
When your state, that stuff held in mutable state of or collected from a flow changes, Compose doesn't just blast the whole screen and rebuild it. It intelligently figures out which composable functions actually read that specific piece of state that changed, and it re-invokes or recomposes only those functions. It then updates just the necessary parts of the underlying UI tree. This highly optimized targeted process is what makes Compose UIs generally very performant and responsive, even with frequent updates.
That sounds incredibly efficient by default, but can developers still mess it up? Can they do things that cause unnecessary recomposition, which might still hurt performance even with Compose's smart?
Oh, definitely. While Compose is smart, you can certainly write code that causes more work than needed. A common way to avoid unnecessary recomposition is to ensure the data types you pass into your stable. Composables are stable.
Stable? What makes data stable?
Generally, immutable data types like basic primitives, int, string, boolean, or Kotlin data classes, where all properties are val and are themselves stable types, are considered stable. Compose knows that if the instance hasn't changed, its contents haven't changed, so it can skip recomposing if the input is the same instance.
Ah, okay. Use immutable data structures.
Exactly. Also, strategically, using remember to cache the results of expensive calculations or object allocations within a composable so they aren't redone on every recomposition unless their inputs change. And, as we touched on with ViewModels, following good architectural patterns helps ensure composables only depend on the minimal state they actually need, reducing the chances they'll recompose when unrelated things change elsewhere.
Got it. Stability, remember, and good architecture. Key performance tips.
Precisely.
Okay, moving beyond individual screens. Apps need to navigate between them. Does Jetpack Compose have its own navigation system? How does that work?
Yes, it does. It integrates with the standard Jetpack navigation component, but provides a Compose-specific way to define and manage it. You use the AndroidX.Navigation.Compose library. It gives you composables like NavHost and tools like NavController to manage your app's navigation stack declaratively.
Declaratively. How do you define the different paths or routes then? Is it like using intents?
It's a bit different from intents. You define your navigation graph using a NavHost composable. Inside that NavHost, you define each screen or destination using a composable function block. Each composable block is associated with a unique string route, kind of like a URL path.
Ah, like web routing.
Sort of, yeah.
Yeah.
You then use a NavController instance to trigger navigation actions, like NavController.Navigate profile screen. You're explicitly defining the graph of possible destinations and navigating between them using these route strings.
Okay, NavHost, composable destinations, and NavController.
Got it. What about the look and feel? Theming. How do you apply themes consistently across a Compose app? Is it back to XML styles and themes? No, it's all done in Kotlin code again, much more integrated. Theming in Compose is primarily handled through the material theme composable.
Material theme. Okay.
Within material theme, you define and provide your app's specific typography, which includes fonts, text sizes, styles, shapes, for defining the corner radiuses and forms of components like buttons and cards, and crucially, colors. Your app's color palette, primary, secondary, background, etc.
So it's like a central hub for the design system.
Exactly. It's the single point where you establish your app's design system. And then all the standard material design composables, button, card, text, etc., that you use within that material theme scope will automatically pick up and apply these defined attributes, ensuring consistency.
That sounds really powerful for maintaining a consistent design language. Are developers stuck with like older material design versions, or is the latest Material 3 supported?
Nope. You get the best of both worlds. Jetpack Compose provides excellent support for both Material Design 2 and the newer Material Design 3 guidelines and components.
Oh, great.
Yeah, there are separate artifacts, Material versus Material 3, so you can choose. This flexibility means you can either maintain an existing Material 2 design system or fully embrace the latest visual language, dynamic color features, and updated components offered by Material 3. It gives you modern design tools right out of the box.
Fantastic. Flexibility is always good.
Yeah.
Okay, one last area. After building all these components, screens, setting up navigation, theming, how do developers actually test them? Can you test composables effectively to make sure they work as expected?
Absolutely. Testing is definitely a first-class citizen in the Compose world. You primarily use tools provided by the AndroidX.Compose.UI.Test artifact. Key things are the compose test rule and functions like create compose rule or create Android compose rule.
And what do those let you do?
They allow you to host your composables in a test environment, interact with them programmatically, like finding nodes by text, clicking buttons, entering text, and then make assertions about their state or appearance. You can verify that the correct text is displayed, that certain elements exist or don't exist after an interaction, and so on. It's a very declarative and powerful way to write reliable UI tests for your Compose code.
Excellent. So testing is well supported.
Very much so.
All right, that wraps up our pretty deep dive into Jetpack Compose. Wow. We've navigated through its fundamentals, explored how to build and arrange UI elements, really clarified state management concepts, and touched upon navigation and theming as well. It really paints a much clearer picture of this, well, really powerful modern toolkit.
It really does. And we connect this all back to that bigger picture we mentioned earlier. You know, considering how rapidly Jetpack Compose is being adopted by major players like the Google Play Store and Gmail, this deep dive provides some crucial insights, I think, into where Android development is heading. And this maybe raises an important question for you, the listener. What does this widespread adoption really tell us about the skills that are going to be most valuable in Android development, say, in the next few years. And how might mastering these core Compose fundamentals we've discussed open up new and, frankly, exciting opportunities for your own tech career?
That's definitely some food for thought. A great place to leave it. Thank you so much for joining us on this deep dive. We really hope this has powered up your understanding of Jetpack Compose and given you some clear, actionable insights to help you along your journey on Tech Road. Until next time, keep digging for knowledge.